Greetings, math fans. All right, so this is day 3, and this is a note sheet, okay, to cover the what the homework is for, of course, the Harper final exam. Okay, so let's get started here. A lot of this stuff is actually a review, so you can kind of look back at old videos too, look back at old notes, but anyway, let's kind of go through this here. All right, so the first thing is find the value of x for x that makes the expression undefined. So here's the deal. Let's say you got 2 over 0 and 0 over 2. Well, if you put this in your calculator, you can maybe even know it, but 0 over 2 is actually equal to 0, and 2 over 0 is undefined. So if it's undefined, that means that 0 is in the bottom. So the deal is, for any of these problems, if I ask you to find the values for x that makes the expression undefined, I only care about the bottom. So like this 5 over x minus 8, for number 1, I don't care about the 5. It doesn't do anything. I literally am going to say x minus 8. I'm going to set that equal to 0. And I'm going to solve for x. Okay? So I'm going to add 8 to both sides, get x equals 8. That's the answer to this problem. X equals 8. So I'm asking you, where is this undefined? Well, when x is 8, think about it. I put an 8 in there, 5 over 8 minus 8. So 5 over 0 is undefined. Okay? So the answer is x equals 8. Number 2, same thing. I don't care about this. This doesn't matter at all. That top part, 7x, who cares? I only care about the x minus 4. So x minus 4 equals 0. Add 4 to both sides. X equals 4. That's the answer to that. Okay, now, sometimes you might have to factor. Like in this case here, again, I don't care about the 4, but it's x squared minus 9 equals 0. Guys, you got to know how to factor. There's so much factoring involved in this Harper unit. You have to know it. If you don't know factoring, there's no chance of passing this unit. There really isn't. Okay, you guys should recognize this is the difference of two squares, because it's two terms. X squared and 9 are perfect squares, and there's a minus sign between. So you should remember it's x plus 3, x minus 3 equals 0. Okay, so I get x plus 3 equals 0, so x equals negative 3, and x minus 3 equals 0, so x equals positive 3. So that's my answer. Oops, x equals negative 3 and 3. That's where it's undefined. Okay, that's all I do. Set that bottom equal to 0, and you're good to go. Okay, so moving on here, is to simplify the following rational expression. So really what you want to do is you want to put this in, you can put this in your calculator too to simplify the fraction part. Like 30 over 24 reduces, if you put it again as using the fraction button, it does reduce to 5/4. So that's what you have to do. It's 5/4. It is, if you know that that 6 goes into 30 5 times and 6 goes into 24 4 times, even better. Okay, but if you don't, when you put it in your calculator, just make sure you type it in the ABC button, and then you actually have to hit second enter to have it, because what it's going to do is it's going to give you 1 1/4, and you don't want that. You want to do that, hit the second ABC button, so ABC, however it looks, okay, and that'll actually convert it to 5/4. Okay, and actually that's the answer to this problem, because there's not anything to do with that y, right? If there's a y at the bottom, you got to do battle, but there isn't. Okay, so the next one, 12 over 12, so it's 1 over 1. And remember, you have a battle, and battle between the x's, who wins? They both cancel out. So the answer to this problem is just 1, because it's, I mean, think about it, it's the same thing over itself, right? If I said a billion over a billion is 1. You know, 1.3 x to the 10th divided by 1.3 x to the 10th is 1. All right. Okay, number 6, again, putting that in your calculator, reduce it, and you would get 4/15. So I'm just going to put 4/15 here. Okay, let's do some battles now. I do the battle of the x's. Who wins? The bottom wins by 2, so it's x squared in the bottom. And I do the battle of the y's. Now remember, guys, that's y to the 1. Okay, so if I do a battle, the north wins by 1, or the top wins by 1, so it's y. Or you put y to the 1. I don't care. Either one's fine. But that's your final answer. Okay, this one, the x minus 7's cancel. And then I would do a battle between the x squared and the x. Of course, the top wins by 1, so it's x to the 1 over 1, or just x. Okay? All right. This next one, you notice, let's just look at the x minus 3 and x minus 3 squared. It's like saying, let's just make it a z, just for the heck of it. If I said z over z squared, do you guys agree that the bottom wins by 1? So, see this x minus 3 and the x minus 3 squared? The bottom wins by 1. So I have x minus 3 to the first power in the bottom. It won by 1. And then I do a battle of the x's. Well, there's nobody to battle with, so x cubed stays on top. And let's do a battle of the y's. Who wins? The bottom wins by 2, so it's y squared. And that's your answer to that problem. Okay, that's not bad. Now we're going to get into a problem where you got to start factoring, guys. You got to start factoring. So y squared minus 81, again, you should recognize it's the difference of two squares. It's y plus 9, y minus 9. Okay, in the denominator, I can do greatest common factor, which is 2. So it's 2 parentheses, and I divide that, I get y minus 9. And remember, you can only cancel out if it's the same on top of the bottom. So the y minus 9's cancel, and I have y plus 9 over 2. Okay, not bad. If you guys remember, I talked to this back in the day. If you have the same thing on the top and bottom except it's just switched, it's equal to -1. Gotta know that. It's like a really important one. So again, I could say x squared y minus 61z over 61z minus x squared y. It's the same thing except just flipped around, equals -1. Don't have to do anything fancy. It's just equal to -1. Okay? This one's a little different. And basically, it's not the same thing on the top and the bottom. We can actually, here, watch. The top, you guys should factor to x plus 6, x minus 6. And the bottom is 6 minus x. So that's interesting, actually. What is that equal to? -1. So negative x plus 6. X plus 6 doesn't cancel. What? That's it. Okay, that's not bad. All right, move along here. Now when you have to add and subtract, and I believe all the problems are going to have like terms in your denominator, so you're not going to have to worry about any craziness in that denominator. But basically, I have x minus 2 over 9. And that's actually the answer to the problem. I know it's kind of weird, but it's like saying, if I could combine that, if I could combine the x and the 2, I would do that, which I'll get to another problem, number 13 here, but I can't combine anything together, so it's just x minus 2 over 9. Okay, this next one, so this is what you want to do, is you want to write z squared plus z squared minus 2 over 4. Okay, write it all together. And by the way, notice it's a plus sign, and we're going to get to problems where there's a minus sign in a second here, but it's a plus sign, so you just kind of add everything together, so you want to getting 2z squared minus 2 over 4. Now the deal is, I can actually simplify this just a little bit more. Okay, and basically I can factor out a 2 out of this top. So divide both sides by 2. I get 2 parentheses z squared minus 1 over 4. And then you guys should be able to do this. 2 over 4 is 1/2, but if you want to put it in your calculator, that's fine. And you wind up getting, so it's really 1/2. And then of course there's still that z squared minus 1. So that's your answer to that problem. I mean, you can put the 1 there, but it's really z squared minus 1 over z. That's your final answer. Okay. 14, kind of the same idea. It's got a plus sign. So 4 minus y plus 3y over 4. So we can combine these two together. So negative y plus 3y is 2y. So it's 4 minus 2y over 4. And remember what I said, if you can, factor. So I'm going to factor 2 out of there. So I get 2 parentheses, 2 minus y over 4. Okay, and then again, you can simplify that guy right there, and you get 2 minus y over 2, because that's 1/2, right? So again, you can put a 1 parentheses, 2 minus y over 2, but, you know, y. Okay, so are we good here? Oh, I made a mistake. I'm sorry. Pardon me. That should be a plus 2y. You're probably saying, hey, Mr. Curvis, made a mistake. Okay, that should be plus 2y. No big deal. That's plus 2y. So it's actually 2 plus y over 2. Or y plus 2 over 2. It doesn't really matter. Okay? All right, so now we got a minus sign here. That's pretty good. So let's do 10x squared plus 1 minus 10x squared over 3. Well, that's kind of nice. 10x squareds cancel out completely, so we just have 1/3. What? Okay, that's pretty cool. Okay, a little more subtraction. So 2 minus 11 over 3a. And guys, please don't do goofy things like 3a minus 3a is 0. That's really bad, right? You don't want to do anything with a denominator. If it's the same denominator, you just keep it. It's like saying 1/2. Let's say 3 halves minus 2 halves. It's 3 minus 2 over 2. Don't do goofy things like go, oh, 2 minus 2 is 0. Okay, that's like really bad. Let's do the addition. If I have 3 halves and I give you 2 more halves, you have 5 halves, right? You don't have 5/4, you have 5 halves. All right, so just kind of watch what you're doing here with that. Okay, let me erase some of the stuff here so it's not all messy. All right. Well, anyway, 2 minus 11 is -9 over 3a. So put it in your calculator, -9. Well, you should know 9 over 3 is -3. So it's -3 over a. That's your final answer. Okay. Next one. Now this is where you got to be careful, math fans. See that minus sign there? 16 plus z minus, and please put that in parentheses. Okay, the reason I say you guys should put it in parentheses is because you got to distribute the negative to both terms. So it's 16 plus z, and then minus 11, and then negative times negative is positive, so plus z. And this, oh, of course, over 5z. I forgot that over this. Here, this is over 5z. Okay, and let's combine terms together. So z plus z is 2z. And then 16 minus 11 is 5. And that's all you can do. You can't factor anything out of the top, right? Like 5 doesn't go into 2, so you can't do anything. So that's actually your final answer. 2z plus 5 over 5z. Okay, a couple more here. Remember when you have multiplication, I'm going to do lots of factoring. So I have x plus 5 here, and the bottom is 3x times 12x squared. And this one, you got to use the x method. Okay, so we're going to have 10 and 1. So I'm factoring this bottom, this x squared plus 7x plus 10. So what multiplies to give you... Oh, sorry, I don't know why I put 1 here. It's supposed to be 7. Sorry. Okay, what multiplies to give you 10 and adds to give you 7, of course, 2 and 5. So that's pretty easy then. It works out well. So it's x plus 2, x plus 5. So the x plus 5s cancel. And then if you want, you can look at these. You can do a battle here. So this cancels out and that becomes just x. The top one's by 1. So, and then again, 12 over 3 is 4, right? You can put in your calculator, whatever you want to do, but you wind up getting 4x on the top. The x minus 5 or x plus 5 is canceled. And on the bottom, you just have an x plus 2. So that, math fans, is your final answer. Okay? All right. This next one, see this division? So just make sure you change it into multiplication. Okay, so let's do that. First, I'm going to factor out a 4 out of this guy. Got to do a lot of factoring. So it's 4 parentheses a plus 2. The bottom is the difference of 2 squares. A plus 5, a minus 5. And I'm going to change it into multiplication and flip that. Now, watch this. So 5 minus a, I'm not going to do anything with that. And I can factor out a 5 out of this. So I get 5 parentheses a plus 2. Okay? So it cancels. A plus 2 cancels. And you're like, wait a second, I didn't recognize that. That becomes -1. 5 minus a over a minus 5. So look what's left over. We have a 4 on top. And let's put the negative there because there's a negative. When I cancel that out as a -1, and then you have a 5, a plus 5. And that's your final answer. Okay? So those are all kind of different problems you're going to have with the Harper test. You're going to have simplifying. You're going to say words undefined. You're going to have adding and subtracting and multiplying and dividing. Okay, and when you add and subtract, you're going to be common denominators, which actually is pretty sweet. Okay, so that is it, math fans. Study hard. Have an outstanding day. Adios. Goodbye.